Today we are doing 2014 paper 2. Now, it says here this, first one, number 1, 6 to the third power is equal to 16. 7 to the 0 power is equal to 1. 0.3 times all squared is equal to 0.09. Okay, we got 739.96 and rounded to the nearest whole number. I end up with 740. The whole numbers are right here. To one significant figure, the first significant figure is 700. To one decimal place, it'd be 740.0. Let n represent the number. Write each phrase as an algebraic expression. The number decreased by 7, n minus 7. The quantity 9 plus the number divided by 4. The quantity plus 9 divided by 4. Now here we go. The hourly cost to employ 7 masons is $94.15. Calculate the hourly cost to employ 4 masons, right? 7 masons is equal to $94.50. 4 masons, I don't know. See that? So I just cross multiply, I get 7 times x, 7x, 4 times 94, I get this, right? Then divide both sides by 7. So the hourly cost to hire 4 masons is $53.80. Now, it says here, 8 masons can build a wall in 5 hours. Calculate how long it would take for 6 masons to build a wall. So less masons mean more time. Makes sense, right? So this is inverse proportion. Inverse proportion, right? So think of it like a direct proportion first. 8 masons in 5 hours as 6 masons is x hours, right? Then you invert this one here. I get x over 5. Masons cancel with masons, leaving with 40 hours is equal to 6x. Divide both sides by 6, and I end up with 6 and 2/3 hours. Next one, we got to find number 5. I have this algebraic expression, equation in fraction form. I got to find the LCD. The smallest number 5, 4, and 10 can go into is 20. So I multiply through by 20. 5 into itself goes once. 5 and 20 goes 4 times. 4 times 3x is 12x. 4 into itself once. 4 into 20 goes 5 times. 5 times negative 1 is minus 5. Minus 5. It's equal to 10 itself once. Into 20 goes twice. 2 times 3x is 6x. So I end up with this two-step equation here. I'm going to bring the 6 over here. I'm going to take the 5 over here. The minus 5 now becomes a plus 5. The positive 6 now becomes a negative 6. 12x minus 6x is going to be just 6x. 6x equal to 5. Divide both sides by 6. X equal to 5 over 6. Here we go. Solve the inequality 11 minus 6x is greater than or equal to 23. I'm going to bring this minus 6x over to make it positive. I'm going to bring this 23 over, making this negative. Always make this the variable into a positive number. Avoids a whole lot of confusion. So I get 11 minus 23 is greater than or equal to 6x. Minus 12 is going to be greater than or equal to 6x. Divide both sides by 6, and I get minus 2 is going to be greater than or equal to x. Now, so or x is less than or equal to minus 2. Less than is going to the left. Because 7 is less than 8, right? So at minus 2, I have a closed circle, and all of my answers lie over here. Number 7. The Earth's orbit about the Sun in a year is approximately a circle with a radius r of 1.5 times 10 to the 5th times 10 to the 8 kilometers. Now it says here, using pi is 3.14, calculate giving your answer in scientific notation, right? So you can change your calculator to scientific notation. Remember that's mode, and SCI. The distance the Earth travels in 1 year. Distance is a circumference, right? And the circumference of any circle is equal to 2 pi r. And should you forget the formula, it's right on the formula sheet on the inside cover. Circle, circumference is equal to 2 pi r, or pi times d. Now coming back here, so it's going to be 2 times pi, 3.14 times the radius, 1.5 times 10 to the 8. Now remember you're working in scientific notation. Just put it in your calculator and you end up with 9.42 times 10 to the power of 8 kilometers. The distance the Earth travels in 1 day. 1 year is roughly equal to 365 days, right? Just divide this by 365 and I end up with 2.5808 times 10 to the 6 kilometers. Here we go, simultaneous equations. This will and must come on the Bgcse. So make sure that you have this mastered. Solve the following pair of simultaneous equations. Now, if I wanted to eliminate x, I gotta find the HCF. The smallest number that x and 2 can go into is 2. But if I want to eliminate y, the smallest number 6 and 7 can go into is going to be 42. Let's eliminate x. So I'm going to multiply here by minus 2. I multiply everything here by minus 2. Everything, the whole thing. Right? The whole thing, minus 2. I get minus 2x. Negative times a negative is a positive, plus 12y is equal to minus 38. And then I'm going to write this back. 2x plus 7y is equal to 0. X's are eliminated. 12y plus 7y is 19y is equal to minus 38. Dividing by 19, I get y is equal to minus 2. Now to find out what x is, I'm going to plug this back into either equation. I'm going to plug it into this one right here. So x is going to be, y is minus 2. So I'm going to plug it into here. I get x minus 6y, y is minus 2, is equal to 19. Negative times negative is a positive. I get x plus 12 is equal to 19. Subtract 12 from both sides. I get x equal to 7. And I didn't do a check here, but you can plug this back into this equation here, and the answer should equal to 0, right? Good. Let's move on to number 9. This is the diagram is a scaled drawing of an island with the villages Acton and Belleville indicated. Now, our scale is 1 centimeter on the map is equal to 15 kilometers in the real world. Now, it says here, calculate the shortest distance in kilometers between Acton and Belleville. Now, here's how we're going to do this. We're going to measure this with our ruler, and I measured 12.5 centimeters. Now, I'm going to change this into kilometers. Our scale is 1 centimeter is equal to 15 kilometers, right? I got 12.5 is x kilometers. Centimeters cancel with centimeters. Leave me with just kilometers. I cross multiply, get x is equal to 15 times 12.5. X is going to be 187.5 kilometers. Now it says here, write down the bearing of Belleville from Acton. So what I'm going to do, from Acton, I am going to Belleville, so I need to measure this. So how do I measure this? You're going to take this instrument here. Now, what I had to do was I had to make this line a little longer, right? Places like so. Some of you all are still not doing it right. Not like this. Do it like this. It has, the crosshairs has to line up where the intersection points, line upon line. As the Bible says, line upon line, precept upon precept. And I ended up with roughly 105 degrees, right? 105. See, I'm using the other one. I get roughly 105 degrees. So this can be 105. Now, if this is 105, I don't even have to measure this. This should be equal to 75 because these two angles are, they are called co-interior angles, and they add up to 180. If this is 75, that means this must be 360 minus 75 is 285. So it says here, write down the bearing of Acton from Belleville. So from Belleville, I'm going to Acton. So the bearing is going to be 285 degrees. A land surveying crew drove east a distance of 96 kilometers from Acton. Calculate the length east from Acton that this would be on the scale drawing. You don't have to draw anything. You're using the same thing up here. 1 centimeter is equal to 15 kilometers, right? He drove 96 kilometers, right? 96 kilometers. So I'm putting 96 over here, kilometers under kilometers. They cancel. Kilometers cancel with kilometers, just leaving me with centimeters. Now what I'm going to do is I'm going to now cross multiply, and I end up with 15x is equal to 96 centimeters. 96 times 1. Divide by 15, I get x equal to 6.4 centimeters. Number 10, circle theorem. All right, here we go. I'm going to find all the angles. Let me work out all of this stuff later, right? What do we know? A angle formed in a semicircle, or the angle formed at the arc, is going to be 90 degrees. So I know, see, this is a semicircle because this is passing through the origin. So this angle here is going to be 90. If this is 90, this angle here must also be 90. Makes sense, right? Now, one of the other rules says that the angle formed between a tangent and a radius is equal to 90 degrees. So this whole thing is going to be 90 degrees. That I know. So I know some things already. Now watch here. If this is 90 and this is 52, I can find this is going to be 38. Angles inside of a triangle add up to 180. If this is 38 and this whole angle here is 90, this is going to be equal to 52 degrees. Right? Good. If this 90 to 52, this must be 38 because angles inside of a triangle add up to 180. Now, CAD. CAD, where's CAD? CAD. That's right here. CAD, sorry about that. It's right here. That's going to be 38 degrees. CAB. CAB is going to be equal to 52 degrees. CBA. CBA. CBA is going to be 38 degrees. Here we go. The polygon below is a regular octagon. What does that mean? All sides are equal in length. All of the angles are equal. This angle equal to this angle, right? Good. And it says here, calculate the size of angle X. So now, what do I know? There's a formula that I gave you guys well, I didn't give it to you. But, or I can just draw how much triangles. I can draw 6 triangles. See, 1, 2, 3, 4, 5, 6. I can draw 6 triangles in here. So it's 180 times 6. So the interior angles is equal to 180 times 6. So that's equal to 180 times 6. And that's good. I think that's 10, right? Now, all of the angles, there are 8 angles in here. So to find out the size of each angle, I divide this by 8. I get x equal to 135 degrees. So every angle here is 135, so x is 135. Bam. How do you find y? Watch here. If this is 135 and this is 135, what do I know about angles inside of a quadrilateral? They add up to 360. Therefore, I get 135 plus 135 is going to be 270. Y plus y, because if this is y, this also is y, because y, these two sides are equal, and this is a isosceles trapezium. That means the two base angles are equal. So I get 270 plus 2y is equal to 360. Bring over 270, I get 2y is equal to 90, y is equal to 45 degrees. Here we go, we have a cylinder. Now, the volume of a cylinder, if you look on the inside cover of the formula sheet, the volume of a cylinder, we can go, let's see if we can turn it real fast. The volume of a cylinder, see, volume is equal to pi, see, cylinder, volume is equal to pi r squared h. Let's go back to this question here. So I say to find the volume. All right, to find the volume, pi, that's equal to, I think it says somewhere to use pi is equal to 20 over 7. Yeah, right here. Pi is equal to 20 over 7. The radius is equal to 1.5 meters times height, 4.2 meters. I'm working out 29.7 cubic meters or meters cubed. Now, the contents of the container are packaged in boxes with a square base of 15 centimeters. Okay, that means that here, I got 15 by 15, right? Makes sense, 15 by 15. But now the height of this thing is going to be, the height of this thing is going to be 20. So the volume of a cuboid is length times width times height. 15 times 15 times 0.2, but I have to change this. Notice something here. These are in centimeters, right? I change these to meters. 100 centimeters is equal to 1 meter, so this is going to be 0.15 centimeters. 0.15 centimeters times 0.15 centimeters times 0.2. And I get 0.0045 cubic meters. That's the volume of each box. Calculate the volume of a box. Okay, so this is the answer for that one. Calculate the number of boxes that can be packaged from a full container. Now watch here. So this is the whole container right here, 29.7 cubic meters, and this is one box. So I divide the one box into the whole thing, and I get 6,600 boxes. Number 12. The formula for the cost of electricity per month B in dollars for the use of E kilowatt hours of electricity is, okay, that's the formula, right? Kilowatt hours. Calculate the monthly bill, right? When 750, so this can be 750 right here, 705, sorry about that. I just plug that in, put it into my calculator, all right, and I end up with $138.70. So the bill is going to be $138.70. Good. Now it says for part B, calculate the number of kilowatt hours used when the monthly bill is 6115, right? So this is 6115. So I'm going to plug that in. Is equal to 40 plus 7e over 50, right? Bring the 40 over, or it becomes a minus. You get 21.14. Multiply by 50. See? I'm going to multiply, see? I'm now going to multiply both sides by 50, and then I'm going to divide by 7. 7 to move the e. I get 151. So the number of kilowatt hours is 151 kilowatt hours. So this is going to be 151 for part B. Make E the subject of the formula, right? So here we go. B is equal to 40 plus 7e over 50. First thing is I'm going to move is the 40. Bring this over, it becomes a minus, right? B minus 40 is equal to 7e over 50. Good. Next thing that we are going to move is the 50. Multiply both sides by 50, and I get 50 times all of this is equal to 7e. Finally, divide by 7, I get E is equal to 50 times B minus 40 divided by 7. That's your answer. There we go. BC. Now, we have all of this, right? So it says here to calculate the BC. So BC, right? What do I have? If you were to draw this again real fast, I get 109. It's going to be 60. And this is going to be BC. I'm going to call that X. Now, if this is a right triangle, how do you find an unknown side given two other sides? Pythagoras. So now I'm going to say hypotenuse squared minus leg 1 squared is, hypotenuse squared is equal to leg 1 squared plus leg 2 squared, right? So I just simply say that this is going to be, X is going to be hypotenuse squared minus leg 1 squared. I get 91 centimeters. Second one, find the angle, length C, right? C. Angle C, sorry about that. So angle C is right here. So I'm going to call it theta. What do I have? Opposite and hypotenuse. I'm going to use sine. Sine of C is equal to opposite over hypotenuse. C is equal to inverse sine of all of that. So the answer is going to be 36.9. 36.9 what? Degrees. All right. Now for part C, the length AD. So I'm going to redraw this real fast. The AD is going to be from here to here, right? So I have this side there, which is the adjacent. I have this side there, opposite, and I got to find the hypotenuse. So I got to find the hypotenuse. So I'm going to use cosine, right? Cosine 41 is equal to 60, adjacent over hypotenuse. Cross multiply, I get x. Cosine 41 is equal to 60. Divide both sides by cosine 41. Cosine 41, and I end up with what? X equals 79.5 centimeters. All right, good. Number 14. Factorize this, right? So I look at what is common. I can divide here by 4, right? 4, 4. So I can pull a forward. What else is common? X is not common to all three, but Y is. I got one Y here. Sorry for that. One Y here, two Y's here, and one Y. So I can pull out one Y. So I can pull out 4 and a Y. 4 into 12 goes 3 times. I write the X squared back. Y into Y goes 1 time, so that's going to be times 1, but I don't have to write that. 4 into 8 goes 2 times. I can write the X back. I've got 1Y into 2 Y's goes 1Y minus 4 into Y goes once. Y into Y goes once. So it's 1 times 1. So that's my answer right here. That's my answer right there. Simplify this. This is just expanding brackets, bringing everything together. 3 plus 7 times that. That's 3 plus 7 and 5 is 35. 7 times minus 2b is going to be minus 14b plus 4b. See that? Good. Adding up everything together. 35, 3 plus 35 is going to be 38. 38. Minus 14b plus 4b is going to be minus 10b. Simplify this. Okay. I got to find the LCD, which is 30. 5 into 30 goes 6 times, so I'm going to multiply this by 6. I get 18. 6 into 30 goes 5 times, so multiply this by 5, and I get 5. 18 apples plus 5 apples equals 23 apples, so 23 over 30, that's your answer. Here we go. I have this. I need to complete this table. So the y is equal to minus 2x minus 4. This is question number 15. So when y is minus 2, I get minus 2 times minus 2 is minus 4. Is negative and negative is a positive, sorry. Positive 4 minus 4 is 0. And when y is 2, I'm going to get minus 8. Good. Now the next thing is we have to draw our graph. And see, this is a graph. And then I have to plot these points, which is right here. This is the equation. You should always write it on the graph. Y is equal to minus 2x. Y is equal to minus 2x minus 4. Good. Now, second graph, right? But okay, it says here, calculate the gradient of the graph in B. Oh, I have the working here when x is minus 2. What is y when x is... Sorry, but I just showed you that. Part C. I'm going to use 0 and minus 4. I'm going to use these 2 points here. And now what I'm going to do... So I'm going to use these. I'm going to use this. And I'm going to use that point there, right? So I'm going to call this x and y, x1, y1. Right? So now what I get, the slope, the gradient of the line is equal to y minus y1 over x minus x1. So I said this is x and that's y, that's x1, that's y1. I get y minus y1 is negative over x minus x1. Negative and negative is a positive, right? I get 4 over minus 2, so the slope is going to be minus 2. And we expected that y, that's in the equation, see, slope is whatever is in front of x, minus 2. Another graph passes through the point 3, 5 and has a gradient of 1, 2, right? What do we know? Using the same thing right here, gradient, right? Is equal to y minus y1. Gradient, 1/2, is equal to y minus, see, and our points are 3, 5, right? Y is 5, x is 3. I get y minus 5 over x minus 3. Cross multiplying, I get 1 times x minus 3. I end up with x minus 3. It's equal to 2 times y minus 5. So expanding my brackets, I get 2y minus 10. I'm solving for y now, or transposing. Bring over the 10. This now becomes a positive 10. I get x plus 7 is equal to 2y. Divide both sides by 2, and this is the equation of the second line, right? Now what I did, I found its value at various points, and it seems like 1 and 3, it gives us nice numbers. So what I did, I plotted these points, and then I ended up with this graph here, right? This graph right here. So this is the equation of y is equal to x over 2 plus 3.5, or 7 over 2. Right, good. Now it says, draw these lines and see where they intersect. They intersect when x is minus 3, kind of, it's slightly off, minus 3 and 2. Okay, let's say, the answer algebraically is minus 3 and 2. But if you're looking at this graph, you will see the answer is going to be roughly, still, it is very close to minus 3, and it is very close to minus 2. So anyway, minus 3 and 2. All right? Now it says here, describe fully these transformations, right? Figure A onto B. Figure A onto B. Where is B? B is right up here. This is a rotation of 90 degrees counterclockwise. See, I'm going against the clock. Right, good. Figure A onto C. A onto C. I made a mistake. I'm sorry. This is a reflection. A reflection in where? This is a rotation. This is a reflection. 1, 2, 3, 4. This is a reflection. This is the mirror line right here. In the x-axis, or the line y is equal to 0. This is a reflection line y is equal to 0, or in the x-axis, the same thing. This one here, A onto C. A onto C. This is a rotation of 90 degrees clockwise. I'm going the way of the clock. Figure A onto D. A onto D. See, if you notice here, this is twice as long. So this is an enlargement of scale factor of 2. Finally, figure A onto E. A onto E. So now A. Let's see. I'm going to count 1, 2, 3, 4, 5, 6, 7. So x is going to be equal to minus 7. And I get 1, 2, 3, 4, 5, 6, 7. Y is equal to 7. Y, if you are going up, is plus. If you're going down, it's negative. To the left, x is negative. To the right, x is positive. So this is a translation by the vector minus 7 and 3. And therefore, we have now completed this paper. Be blessed, be encouraged. I hope you do well in the exams.